Hello, CET 103 students, and welcome back for the video series on horizontal curves. I hope by now you've had a chance to do the reading in the textbook. Today, what I'm going to try to do is talk to you a little bit about the information on the initial set of slides that I sent. By the way, I have updated the slides, and I ask that you go out on Blackboard and get the latest set of slides. And I've taken a little bit of information out. And I've also added a supplementary set of slides that will sort of help us through today's lecture. I encourage you to go look at the instructions for today's lesson. Pull those down if you haven't already, and make sure you've looked over that. Make sure you've looked over and you've pulled down both sets of slides for today's lectures. As I said, today is going to be about horizontal curves. Horizontal curves are an important part of the civil engineering process, and important, particularly important in roadway and any sort of highway or railroad layout. The purpose of the horizontal curve is to help transition from one straight piece of roadway through another piece of roadway and make a smooth curve from one tangent to the other. We'll be talking about some of those terminologies as we go along. So I hope you all are doing well in this time, and I look forward to our next series here. So let me go ahead and start out with the slides. I'm going to start out by calling up the first set of slides on construction surveying. You guys have already had a chance to look at these, and so therefore I'm going to pull them up here, and as I said, I did edit them, so I encourage you to go back on and see the information with the new edits. I am also going to come over here and pull down my presentation here. And I'm going to pull over my pointer presentation here. And I'm going to go to the laser pointer as we talk about. I'm going to go back a few slides here because I want to start this section on horizontal curves. As you remember last, we left off on slope staking. Today, we're going to talk about horizontal curves. So in particularly horizontal curves, have two major types of curves that we talk about in this class, and that we usually handle in the surveying and engineering industry. Although there are different deviations of these two types of curves, these are the main two types of curves. I'll start out with the first one being a circular curve. The majority of what we'll be talking about in today's class, and in all the classes we'll be talking about, are going to be just circular curves. Spiral curves is the next one. A spiral curve is a little more complex, and we won't be covering that in our lecture series today. Or for the remainder of this semester, that would be covered at an advanced class in surveying. First of all, let's start out with the circular curve. The circular curve consists of what is called an equal tangent curve when both tangents are the same length. A simple curve, the best way to think about a simple curve is that it has one continuous radius. That is the big difference between that and the spiral curve, which we talked about a few seconds ago. The spiral curve actually has a changing radius. So a simple curve is one that has a consistent radius. And if you see right down here in this diagram right here, this is a very basic simple curve. We've got a tangent length coming in, a tangent length going out, and a curve that curves between one tangent to the other. This radius distance is the same anywhere on this type of a curve. So this is for what we call a simple curve, or an equal tangent curve, and one that holds the same radius. Here are some deviations of simple curves, and they are all simple curves, but there's a few ways of using curves in different manners along the roadway construction process. This one here is what we call a compound curve, where we have a curve and another curve going into a curve. This is what's called a broken back curve right here, where we have a piece of curve that's our radial one consistent radius curve right here, a short straight tangent piece in here with another small curve. But again, two simple curves there. Here in the compound curve, two simple curves. And then this one right here is called a reverse curve, where we have a straight tangent going in, a straight tangent going out, and then we have a circular curve with a consistent radius here on one end, and then the roadway turns back in the next direction, and it sort of S's itself back in here. And this is another curve where we're actually finishing off a curve and beginning a new curve. Again, these are two simple curves. So these are just different deviations of simple curves. The simple curve, the compound curve, which uses two curves, the broken back curve, which uses a curve, and a tangent, or the reverse curve, where we have curves going in both directions. Again, the latter three being simple curves, just having multiple curves versus the first one only having one curve. A spiral curve. Now, a spiral curve is different, and as I mentioned, we weren't going to spend much of our time talking about spiral curves, but I do believe they need some sort of recognition in that the surveying student understands the difference between the two. A spiral curve is one that actually has a circular curve or a simple curve contained within it, but in the little piece that runs from the straight length to the spiral curve is a small curve right here. That small curve right there is what I would like to use the term non-radial, meaning that the radius is consistently changing here, versus the simple curve where the radius stays the same. The purpose of a spiral curve is sometimes to help the driver or whoever the user of the roadway would be transition and get ready to move into the circular curve. This helps with high speed conditions. Also, a good example of a spiral curve and the need for a spiral curve would be in a situation where we use a railroad curve. A railroad, you think about a railroad train, if a train was coming down here, this train had to make this transition here. Remember, a train is a big rigid piece of metal. It's not like a car that it has a turn radius that's shorter. So therefore, the spiral curve sort of has to get prepared to move its way into the circular curve. So that is the reason for the spiral curve. Here are some examples of three types of spiral curves. This spiral curve is between two tangents. This is what we call a double spiral here, where it comes in with a tangent, out with a tangent, and then two spirals leading in and out of it. Again, remembering that these curves are non-radial, so the curve keeps changing its radius along the way. And here we have a circular curve between a spiral between two circular curves, where we have a consistent radius curve here, which is a simple curve or circular curve, a consistent radius here on the back end, which is a simple curve. And then in between them, transitioning from one to the other, is something that's called the spiral curve. The spiral curves are used quite often, but they're a little more complex in the layout, and oftentimes they're only lead into and out of a circular curve, and that is usually the common practice in most highway layout. In railroad layouts, it's a little bit more difficult, but you will get that at a later surveying class. The next thing is the elements of a simple curve. So this particular sketch that's off here on this set of slides is a very common set of sketches that's used in most definition of simple curves. And I recommend that you all learn the aspects or the elements of a simple curve and be able to identify them. For those of you who plan on taking the Fundamentals of Engineering exam, it's distinctly possible that you'll encounter the elements of a simple curve, and I really recommend this diagram as one of the ways to remember. Off to the side of both slides 29 and 30 are different components of the circular curve. But before I go into that, I am going to stop the share here, and I am going to head into the second set of slides that I've brought in to supplement this series. Okay, let me escape out of this, and I am going to share the other set of slides here. Let's go into a new share here, horizontal curves, and I will be using this set of horizontal curve data. Okay, so the reason I brought this set of slides in is to help you sort of understand the horizontal curve process. I know it's hard to get your mind a little bit around this without having years and years of experience in this. So I've used this set of slides. I'm going to be using this set of slides to help us demonstrate that. Let me go back in and pull up my pointer here. And actually, I think I'm going to pull up my highlighter as we go through. Okay, I am going to start now with the first set of slides here. And the reason I pulled this one down is it helps you kind of define what a simple curve is. The photo you're seeing in the upper image up here is an actual photo of University Boulevard. This is Highway 47, just east of the university campus. And it's probably a roadway that many of you take on a daily basis going back and forth to the university. This lane that you see right here that I'm showing with the yellow box there is the eastbound lane of University Boulevard, or Highway 47. This lane right here is the westbound lane. This overpass that we're seeing right here is the overpass that goes to Jerry Murphy Road. Many of you may be familiar with Kwan's Kitchen. That sits right there, and off into this distance over here would be where the Big Lots store is located. The reason I pulled this one in is it helps me explain to you guys a little bit about what a horizontal curve is and how it is used in highway construction. And then I have a set of highway department plans just below it here, and it shows how the plans coincide with the actual construction plans. So here are the highway plans that were done prior to the construction of this roadway, and now you can see that this roadway now is the result of that being built. As I said, these are Department of Transportation highway plans. So as you can see right here, here's our Jerry Murphy Road. Here is our Jerry Murphy Road. Here is the plan, and right here is this off-ramp that we see as we come off. So this would be a good example of a highway, of a need for a horizontal curve. Here, as we're transitioning in from a straight piece, and then we would be heading to another straight piece. Well, we can't just directly turn off on that, especially at some sort of high speed or high rate of traffic. So therefore, what we would do is we would have between this straight piece and this straight piece, we would come in with some sort of a curve that would slowly transition from this tangent to this tangent. Right here would be an example of where that information is given in the set of highway department plans, this being the center line of the road. Then the roadway straightens out, as we can see right in this particular area here, it flattens out. And then the roadway goes into a large curve right here, which is right here. This particular section of highway has, I think, 3 or 4 multiple curves in here. Here's one curve right here that transitions from this straight piece, which will be coming off of here, to this straight piece right here. So we have a small curve right there. We have a straight tangent right there. We have another small curve right there. I think a larger curve as we transition into the curve right here. All of this information is given in the curve data here on the Highway Department Plans and Specifications. And I will be using for you all some of this information and how to calculate this information. We'll be talking about some of the components of that here in just a little bit. So with that, I am going to head on to the next set of slides. The whole purpose for this set of slides was to give you an idea of how a highway department curve actually exists and where it should be used within the context of a project like this. Okay, now I will head on through back to the next point. So here is the diagram that I showed you earlier, and I want to demonstrate for you guys some of the key elements of a horizontal curve. The first one here is what's called the deflection angle, or the internal angle here. You'll notice up here that it shows like the letter I, or it's termed as the deflection angle. That's the two symbols that you see here, I, or this deflection angle here. The I, or deflection angle, is actually defined by showing this tangent coming into the curve, this tangent going out of the curve. So if we were to have that sort of a situation along a highway roadway, as you could imagine, if we had to do this, we would actually have to have traffic stop at this intersection and then transition down into the next area. So what we would do to prevent that would be to put a curve in here, so a traffic flow could come here, continue at a rate of speed, transition around the curve and into the next tangent very smoothly. So therefore, these two tangents that are formed here is the tangent going in, the tangent going out. I use the term tangent because they're straight pieces of lines, or straight lines that intersect at a particular point. That central angle, it would be the angle that is formed if we were to take this first line and extend it past in this second line. It would be the angle that deflects or goes back to the point right here. So this point D right here, that is shown right here, is what is going to be called the deflection angle right here. The deflection angle in a simple curve is also equal to this right here, which is the distance, or the angular measurement, between the point where the curve begins on one tangent and ends on the other tangent. So these two angular measurements are exactly the same, and that's defined as the delta angle, delta, deflection, or central angle right here. Also, the I actually comes from the term intersection angle. The next point I'd like to pull your attention to is something called the radius. The radius is the distance if we were to take this tangent line and the point at which this began here, and we could turn a 90-degree angle back, and if we could come over here to where the curve ended and turn a 90-degree angle back, where these two points would intersect would be the radius point. The radius point, the radius distance, is going to be the distance from that radius point to that point along the curve, and then anywhere else along the curve here. So this letter R, or this distance R right here, or the radius, is a important point, and it determines the curve. If you remember earlier when I talked about simple curves, we talked about this being the radius point for that particular curve, and that distance along the way being consistent throughout the same radius. So that is what is defined as the radius. The next point I'd like to call your attention to is something that's called the PI. PI is the point of intersection. The point of intersection is defined as the point at which two tangents will intersect each other. That would be this point up here, this point C. The point of intersection is a very important calculatable point in the highway construction process, because it defines it actually sets up the parameters of the curve. So this point is very commonly used in the practice. It's more used for computations than it is for actual construction layout. This point right here now, which is the point of curvature, or the PC, is the point where the curve begins. So one of the things that one must always establish when laying horizontal curves out is the direction in which the curve is flowing. This particular curve is flowing this way. The reason I say that is because I would look at my stationing of my roadway and see that my stationing increases in this direction right here. If I were to come back from the PI right here, a distance to this point A, that point A being the point of curvature, that point of curvature is where the curve begins. The PT, on the other hand, or the point of tangency, if I could come back to that PI and go that same distance that I went from here to here along this tangent, I would end up at this point right here, which is designated by the point J here. J is the point of tangency or point of tangent where the curve becomes tangent again. This distance, which is defined right along here, is the tangent distance, and that is the point of tangent. What's key about this particular type of curve, or a simple curve, is that this length and this length are exactly the same. And that is what's defined as the tangent distance. The tangent distance is very important in the computations. The next thing we'll talk about is what's called the long chord. The long chord is the distance from the straight line distance from here to here. That's this point right here, or denoted by our symbol K, and that is called the long chord. The next one is the length of the curve. The length of the curve is defined by this length right along there. The length of the curve is deceiving. And the reason it's deceiving is because it's hard to compute that or actually lay that in the field, because it's not something we can directly measure to, because it's a point along an arc. So therefore it's a little more difficult, but it's very important in the computations, and it is crucial in the actual construction layout. The next thing is what's called the external distance. The external distance is this distance right here, which is the distance from the PI, the point of intersection, back to the middle of the curve, or the point of intersection, or I'm sorry, the external distance. That's this distance right here, or what is defined by the letter F right here on my sketch. The next thing, which is the mid-ordinate, the mid-ordinate is defined by this point right here. That is the distance between the center of the curve and the center of the long chord. That's this distance right here, denoted by the letter H. That is the mid-ordinate. The POC here in our information is a point along the curvature, or point on the curve. This point indicated right here in the letter I is actually a point on the curve. There can be multiple points along any of the points along this curve. This is just denoting one of them. The next one here is a point POT, which is a point on the tangency of the curve. And that can happen anywhere along one of these tangents along the way. This point E right here is a point along the tangent, or a POT, point on tangent. I will finish this set of slides here, and I'm going to encourage that you go back to the readings in the textbook and look over the information on how to lay out the horizontal, or not how to lay out the curve, but the elements of a simple horizontal curve, and define those components we just talked about in the last set of slides. That would be all of these pieces of information. you will be required to have to know those pieces of the curve for the final exam. I will stop this video series here and then moving into the next video series to follow. Thank you. And that ends the first set on Module 3, horizontal curve elements. I'm going to stop the share and I will stop.